until you?
You can leave it on.
Okay.
Okay. Happy Thursday, everyone. What we're going to do here per webinar rules is we're going to take a couple minutes and let people start to trickle in. And then we're going to go ahead and we're going to get started with the session today on the challenge of 3D data integrity in aerospace. So I'll just give it a couple minutes and then I'll just go ahead and I'll do formal introductions of the panelists and we'll take it away. Scott, how are you doing today out in Columbus, Ohio?
I am doing great. It looks like the sun came out. It's been raining most of the day, so.
Yeah, that's awesome. That's awesome. Mr.
Always
Lloyd, how are
enjoy
you
the
doing?
sunshine. I know down in Texas, you get a lot of it.
We do get a lot of it. We get quite plenty of it. And man, right now it is just beautiful. As Andy and I were talking about earlier today while we were preparing for the session. So, Mr. Lloyd, how is it where you are?
It's probably the same as how it is with Scott, really. It's that it looks like a British summer's day out there. Grey and wet.
Gray and wet.
Pleasure
Awesome.
to.
Well, I mean, Ohio is still like really, really beautiful. I'm a big fan of Ohio. I'm also a really big fan of the Ron Swanson artwork that you have sitting there right behind you. So with that, we're about 2 minutes past. So we're going to go ahead and we're going to get started here. To my panelists, can I get a quick thumbs up that you can see the screen okay?
Yeah.
Wonderful. Thank you. So great to meet everybody. Thank you all for tuning in and taking time out of your Thursday afternoon, morning, late in the evening, wherever you might be. We're just really grateful that you've come here to join us and sit down for this session on 3D data integrity in aerospace. I'm going to do some quick introductions, and then I'm also going to walk in through some of the protocols of how we're going to approach this particular session. But first and foremost, I want to do a quick round the horn. My name is Bo Mangles. I lead enterprise marketing for all of Physna Enterprise. I will be speaking to you for the next 10 to 15 minutes talking about the core subject matter. I'm also then joined by Scott Shipley, who leads sales engineering and architecture for us at Physna, who's going to dive into the product technology itself so that you can see it firsthand and understand some of the key points that we're trying to make around how Physna can help impact the topic of data integrity within your organization. And then I'm also joined by the esteemed Andy Lloyd, who is our head of customer success here at Physna, who's actually the biggest subject matter expert of all when it comes to just about anything when it comes to aerospace, having spent 34 years in the Royal Air Force, as well as with NATO, and including the past 5 years of service as Deputy Director of Logistics in the U.S. Air Force Sustainment Center. That was a mouthful in Dayton, Ohio. So we're really grateful to have this like really good set of crew with us today to help walk you through through our talk track. Before we jump right into it, a couple of the house rules. We want this to be as much of an active dialogue as possible for those of you who are tuning in and attending. We also want to be mindful of time. So the way that we are going to structure that is we have a Q&A box down within the Zoom bar that you can go ahead and click if you have questions during the demo or any of the talk track that we have. Additionally, we're going to set aside about 15 minutes after this so that we can help answer any questions that you have live right here within this space. And so with that, we're going to move right on into it. Next slide. So, and yes, it's like so the challenge of 3D data integrity for aerospace, this is the topic of conversation. And this is going to be, for those of you who have been following Physna quite a bit, this is the first in a series of conversations that we're going to lead around some of the core challenges that our customers and prospects are bringing to us in the field when we meet with them. And so we've got a strong amount of these that are coming down the pipe. We have one that's going to be coming down a little bit later on, about 2 weeks from now, focusing on supply chain resilience within automotive. And I do really want to emphasize, if you aren't immediately within the aerospace audience, and those are maybe for folks who are watching this after the fact, you're still going to find a lot of value in this because we see these trends across a lot of different industries. But for this in particular time, we're going to focus specifically on aerospace. And why do we want to do that?
Hey, Bo, can I just interrupt you real fast?
Yes,
We're not seeing your slides that you're sharing.
You're not seeing my slides that I'm sharing?
No, sir.
Okay, sorry. Let me go ahead and share. Desktop 2. Okay, can you see it now?
Yes.
Okay, when I click and present, can you see it now?
Yes, we can.
Okay, we're good? That's why I asked for the thumbs up beforehand. Awesome. So thank you, Scott, for jumping in on that. Always the best when it comes to sales engineering. So thank you. Back to it. The reason why we're here is because all aerospace manufacturing outputs depend on 3D data. The really important piece that I want to call out is what defines 3D data. And this is something that might seem rather trivial, but it's really something that's super important for us to be able to clarify at this point. So what we mean by 3D data is any of the reference models or architectures or assemblies or sub-assemblies that you and your organizations develop that then go out, are manufactured, and then added into the parts themselves. That's everything from brake rotors to wing assemblies to the glass on a windshield that you see. That is when we think of 3D data, of what that means. Now, when it comes to the topic of data integrity, a lot of that reference comes back to more so of the 2D data. Like, what is the data that is coming off of those 3D parts that are developed, largely done with the proliferation of like IoT. So that's the quick disclaimer on what we mean by that when we want to go into that and talk about that in more detail, because understanding the relationship of 2D data is really beneficial when it understands what it does to the 3D models that we build that go into each of the parts that we see. And so, Scott, I'm just going to confirm you can see this slide.
Yes, we can.
Beautiful. Thank you. The 3 common data integrity challenges that we come across today are increase in data volume from internet-enabled parts, largely many folks are probably familiar with this. It's called Moore's Law. Moore's Law is the general understanding that it's like over the course of time, technology becomes cheaper and cheaper, which allows more things to hold technology. And the same thing with semiconductors. It's like they get smaller, you can then apply them to different things. So we have more and more part data that's coming off of those parts that you now can see. The second is the lack in universal data standards. This is something that's true within aerospace. It's something that's also true across industries as a whole. Everybody has different ways of the way that they manage their own data. And that goes down to even the divisional spaces that you go and you work with. You have one department who has one set of standards, you have another department who has another set of standards. And those things become challenging when it comes to data sharing and throughput and going back and forth with reference architectures. And then the last thing is a slowly evolving technology stack. You know, this is true. It's like technology, especially like heavy technology that's used for manufacturing, it takes time and diligence to be able to create and make sure that it's purpose built for the things that you need. So I'm going to go into each one of these in a little bit more detail, starting the increase in data volume from IoT. Over the past 20 years, we've seen this explosion in the market, especially from about the time of the last 5 to 7 years of new airlines, new manufacturers, new OEMs, building out specific unique data platforms so that they can so that they can access all of that new smart data that's coming from every single part that exists within a plane, which is a great thing. It's like, those are really great things. They help improve security standards. They help improve so many different aspects of the plane development itself, that you are really left with this really rich set of data, or that's sitting within this data lake that you can then access and use. And you have folks and service technicians who are able to access it more readily. You have engineers and designers who are able to see what's happening, like from the service technicians levels. There's a lot of different benefits and value that comes from that specific thing, but there's a lot of it. And one of the things we talk through is more part data yields more parts and greater margin for error when it comes to developing those parts, which is where reconciling that becomes really important for a business and for us. The second is the lack of universal data standards. I've included two quotes here because this is something that comes up quite a bit when we speak with customers and we talk about what their specific use cases are. The first one is what we referenced earlier in a couple slides before. You have a lot, like different divisions use different systems for understanding their unique sets of data and their data challenges. That becomes hairy when you start building more agile development methodologies from like end to end. So if you're using service tech to customer service rep at the end of the line, there needs to be a really good, strong throughput of communication in that. And then including one of our own, quotes from one of our own, Dr. Christoph Rodig, who's our director of engineering here, the only standard that we've found when meeting with customers is that there is no standard. And so this is something that becomes really important to reconcile as like we're going out and developing these processes alongside our customers. And the final thing here is the slowly evolving siloed technology stack. This is one of the core pieces when we sit down with folks that comes up quite a bit, which is you have service techs using one set of tools, product designers and engineers using another set of tools, and then you have procurement professionals using a third set of tools. This is all, like all of them are very, very purpose built. There's a lot of customization that goes into those things. But one thing that pops up quite a bit is they don't communicate well together. And so when they don't communicate well together, you have engineer A who builds part A, you have designer B who builds part B, and they might be the same part sitting in the exact same space. And you're not readily going to reconcile that because that's not something that could be top of mind because you haven't had a system that's been able to do that in the day. And these are the things that when we take a step back and we look at the industry as a whole, that are really dramatically impacting the way that people build, develop, and bring products to market. This is where reduced trust in data or data integrity really comes into play. Imagine, it's like, let's take a look at those three challenges from end to end. You've got a whole bunch of data that's coming off a plane. You then put all of that good, clean, like diagnostic data that goes then to sets of service techs. You then have it going into engineers and you have it going across procurement groups. All of that stuff then gets siloed off into different spaces, redeveloped and recreated. And you're not going to know whether or not you should trust it. And it's your job to make sure that you have that level of integrity across everything that you build. So Harvard did a giant study on this, which is where we get a lot of this data from, which is up to 50% of engineers' time is spent double checking model data because it's not maintained in a salient way. And that is time spent that they could be using to go design and build new parts for your plane, or stuff that they could be doing to go make parts that much better or more efficient. This leads to an average estimated cost. It's like 400%, engineering costs are 400% higher than they should be, which is a really important thing to wrap your head around, especially as we're looking into a world where interest rates go up, inflation goes up, everybody is looking at that. So if you have areas within your business where it's like you can pull that stuff down, it becomes really advantageous for all of us to be able to take a look at it. And the last thing here is a smaller stat, that is around like scrap rates. When what we see within this is scrap rates are actually roughly accounting for about 4% of sales because that data or because the parts that they built aren't usable. And the reason for that is it's like you have data going back and forth, it's changing hands. You might get something that you don't have. And 4% might not sound like a lot, but if you amortize that out, it's quite a bit. So it's like, if you look at 50 million bucks, like that's $2 million gone. And so those are all things that are just eating into your own margins and slowing the time to market and increasing procurement costs across the board. Sorry, that was a lot. And now I'm going to transition more into where Physna can kind of help out and play into this. Physna helps improve 3D data integrity across all of your 3D reference models and designs because it gives you a shared space where it's like where service techs, product designers and engineers and procurement professionals can go and see a clean, unified version of all of your 3D models across all of your existing systems of record. And some of those things are what Scott's going to go in and share here in a couple of minutes. But the way that we're able to do that is because we're taking a look at all of those reference models based on 3D geometric search, which allows a precision and understanding that a lot of shape search tools just aren't able to really grasp and get. This allows you to improve collaboration, reduce design times, and reduce waste across the board with what you're doing, all because we were able to go and granularly look at the precise geometry of the model that you develop and analyze that across a number of different facets, which Scott's going to go ahead and show. The second piece is this. It's the platform itself that we've developed allows you to like compare things side by side, view things in more detail, but it does so within an interface that makes it easy for you to be able to access and understand. You don't need access to an expensive CAD or PLM or other ERP license to access Physna. It's like you just access Physna. It's like your models are there, and you can then reference that across all of your other existing systems of record. So the part in that is really when it comes to access and for you to be able to see where that data lives and how you can go and tap into that in real time. And then the final thing, which we talked about when it comes to procurement, this is where it's like we start to get into the supply chain movement. Making smarter procurement decisions based on the best data set possible is critical. And if you have all of the right models, you're then able to really effectively tell where it's like where you should be buying these parts. And what we mean by that is, let's say you take, using the reference example that we have here, you have you have bolt 1 and bolt 2. Bolt 1 could be purchased or procured by Bo's supply shop at 0.02 cents per unit. The second bolt could be procured from Scott's supply shop because he gets a better deal, 0.01 cents per unit. And from that point, you now understand it's like where you can actually go and negotiate better prices for the tools or for the parts that you need in order to build these assemblies within each of your models, but also that go and bring your product to market. So that was a lot, but it's like, hopefully it's like you're starting to get a good grasp and understanding of both the world of data integrity, but also translating that aspect of 2D data into 3D data. And with that, I'm going to actually turn it over to Scott, who's going to walk you through the product in detail and talk through some of these things that I've just shared with you today. Scott, awesome. Over to you.
Yeah, thanks, Bo. So I'm excited. I get the maybe the fun part where I get to run you through our actual product, but
you get a lot of the fun part.
I think one of the things that you'll see is we have some really innovative technology, and we would argue it's the future in harnessing the full potential of your 3D data. But, you know, as Bo mentioned, Physna is a cloud-based AI software, and we're able to uniquely break down the structure of 3D models so that we can do advanced analysis, search, comparison, classification, etc. So how do we do all that? Well, we start with taking those existing 3D models and leveraging machine learning and other advanced mathematics that we've proprietarily come up with. We can make those models accessible and searchable and ultimately actionable so that you can apply the knowledge that you gain from Physna to a broader range of use cases, such as reducing design hours. So we hear this a lot from customers. How do we reduce complexity? Right. A key component of reducing complexity is understanding where maybe we have duplicate parts or parts that are similar to one another that when we're redesigning new, or maybe we just didn't know that we had duplicates, right, as Bo just kind of talked about. So that's an area that addresses a number of different factors, from procurement to supply chain to a lot of different things. And ultimately, what we want to do is enable deep learning, right, and insights across your 3D data. So let me go ahead and share my screen here, which I think, Bo, I'll need you. I'm just going to say yes, and it may stop you from sharing. All right. So you can see my screen okay?
We can see your screen just fine, Scott. Thank you.
Awesome. So I'm going to start with our consumer-based site, which is called things.com. And why I like to start here is because the core underpinnings of things.com really are what our enterprise product are built on. In addition to that, you can see right on the main site, we have over almost 12.5 million models. And so this site is designed really for a lot of enthusiasts to be able to share 3D models with one another, you know, for 3D printing and other such areas. So what I'm going to do is I'm going to show you, you know, you can do some pretty unique things with the Physna product. So I'm going to click here on this little button, and I'm going to browse, and I'm going to pick a part file. So this is a native CAD file that I'm going to hand to things. And what it's going to do is it's going to search through those 12.5 million models that are out there. And it's going to come up and it shows me, okay, here's the actual bearing that I just provided to it. And I did all this through a web browser. I'm using Google Chrome in this specific instance, right? I don't have any fancy CAD license or model, no specialized hardware that has to be done. You can even do this from mobile devices. So what's interesting is you see the bearing, but what you also see is this turbocharger. And if I go ahead and click on the turbocharger, it's going to load up here, and you can see that I can do things like explode this model. So if I break it apart, I can kind of see what are some of the components that are made up of it. And what's interesting is the bearing that I was looking for, you can actually see within the model. So over here on the right-hand side, you see a traditional assembly that you would maybe see within your CAD system. And as I scroll through the assembly tree, a really interesting part is that you don't actually see the bearing listed. And the reason why you don't see the bearing listed is because it's actually the bearing is part of a subassembly called the impeller axle. And if I click on the impeller axle, I can actually bring that up. And sure enough, you can see, here's two of these bearings that I was looking for. What's really interesting about that is I did this search. You watched it real time, extremely fast, in a second or less. But what's interesting is I did this with no metadata, no information about the part other than the unique 50-step process that we go through to determine the exact geometry of the product, convert that into, think of it like a fingerprint or DNA. We call it the Physna DNA or PNA for short. And that allows us to be able to do all kinds of really advanced comparisons. So I wanted to start there. What I'm going to do next is I'm going to kind of go from our things offering, right, which is a free offering that I mentioned, and we're going to move into the enterprise product. So let's say that I want to go through the same search again, and this time I'm going to actually type and search for bearing instead of giving it the file. So you see in a slightly different way, instead of giving it a CAD model, I'm doing a traditional search, and it's searching for everything that's actually called bearing. And so if I go ahead and see the bearing here that I want, if I click on the actions menu, there's this option called match. And what I can do with a match is I can say, hey, I'm sorry, I'm going to click on part match actually. And what I can do with part match is very similar to what I showed you with things, is I'm going to say, can you show me where this bearing might be used in another part? So I do that. And what happens is that Physna actually comes back and it says, hey, within our database, we found that this part exists in a few different places. It exists in this turbocharger as well as the impeller axle. So I'm going to go ahead and click on the turbocharger and bring that up. And one of the features that you'll find within our enterprise product is that we have this option called assembly tree. So I'm going to go ahead and click on the assembly tree. And here you can actually see every specific 3D model that makes up the assembly of the turbocharger. So as I scroll down, I'm just going to click on this bolt, and I'm going to open it up, and I'm going to show you another feature that we have. So here's the bolt, and it's nothing fancy about it, but what I'm going to click on is this option under actions called compare. And if I go ahead and click on compare here, you can see that I've brought up in our viewer the turbocharger itself, and you can see the actual bolt here. But we can start to do things like what we call dialoguing, with our 3D data. So if I hide the bolt here and ask Physna, could you tell me where within this turbocharger, where does this bolt exist? And so I do that by selecting this box, and what you can see is that it very quickly found all of the locations where that bolt exists within the turbocharger. Now, another really cool feature is that this is what differentiates our product from other products that are on the market, and I said that we're uniquely, specific in how we kind of approach this, is we're not just doing shape search. And what I mean by that is we're not taking, data with bounding box volumes and all of this other stuff and trying to apply metadata and all these things to show you this information. That's how we can actually find a part buried within a subassembly, right? So when I showed you the bearing buried within the impeller axle, which was then buried within the turbocharger, you'll never be able to do that with shape search. But I have this option to be able to adjust the opacity, and just to kind of prove that it's not shape search, you can see that within the turbocharger itself, I can see, every single example of that bolt. So that's one really cool feature that definitely differentiates our product. So let me go ahead and show you another enterprise feature, and it's what we call photo to 3D. Now there was a question earlier in the chat. Someone was asking about 2D to 3D, in relationship to data. So let me kind of quantify what I'm going to show you. I'm not showing you here's a 2D image or drawing of something and now I'm creating a 3D model. It's a slightly different use case. So what I'm going to show you is a really common feature, and this came from one of our customers who said, I would really like to be able to do this type of scenario. So let me open up the photo to 3D, and I'll kind of walk you through the scenario. So imagine that you're in a situation where maybe you're a maintenance worker and you've gotten a call that the machine that you're helping to support has gone down. Maybe that machine is manufacturing brakes for an airplane model or some other thing. And so you go out to the machine, you find the broken part, but there's no part number on it. It's kind of worn. You're not 100% sure of what this actual broken part is. So we have this thing that I mentioned called photo to 3D. So let me go ahead and get into that by clicking on our classify image. And from here, what we've done is we've actually trained, using neural networks and machine learning, a bunch of models. So we created thousands of models based off of these CAD images, so that then I can do things like, let me give Physna a picture that I took, and this could be a JPEG, a PNG, whatever. And in this case, I'm just going to give this picture of what I'm calling a broken part. And I'm going to go ahead and feed that to Physna, and Physna is going to come back and it's going to say, okay, I see the broken part that you found, and here's some different options that may be related to that part. Now, I know enough about the part that I gave to it that it's a cylinder stopper that's made by, it's a standard part that you can buy from a number of different companies. But here you can see is the case of that part. But here's the actual part that I'm looking for. And what's interesting is then there's an assembly that was also provided here. So if I go ahead and open these two in new links here, I'll show you what we see. So here's the first part. You can see it is actually an assembly. It's made of the stopper as well as a filter and the housing itself, which is pretty cool. And if I come back to this assembly, you can see that if I zoom in on it, there actually is the different parts. So I can do things like, come and isolate like that part from the assembly. And sure enough, I can actually see this is what I was kind of looking for. So that's a really great feature that a lot of our customers love. I'm going to transition and show you another feature, which is what we call match and compare. So let's say now that I have this specific part. The part number for it doesn't really matter, but I'm just going to type it in here and I'm going to do a search. So through our search, you can see that we've returned a number of different parts, and the part that I'm looking for is this one. So I want to use this option called find matches. So what's going on is Physna is actually searching through all the different models that we have to find a match that is similar or identical to some percentage, right? Like it could be 100% identical or some variation of that. And we can kind of choose what that looks like. So let me go ahead and click on find matches. And Physna is now coming back. You can see it found 18 results, and it tells me here what the percentage. So it found a number that are straight duplicates of this exact part. And if I scroll down, I can see that as I start to get down, I can see that there's some differences. So this specific one is an 89% match. Here's one that's also 89% match. So I'm gonna show you a feature that we call compare. So I can actually click here on this, and it opens up a comparison viewer. Now, what I can see is I can see the housing on the right. I can see I'm comparing it to the original full cylinder stopper assembly, and we're doing things like highlighting the difference here. So you can see from the outside, from what I can see in this view, you can see where we highlighted the differences. Now, there's another feature called our new comparison viewer, which gives us a different perspective of it. And one of the things that's kind of nice that I showed with the turbocharger and the bolts is I can actually, again, adjust the opacity of the outside, and I can see, sure enough, here's the actual differences. Here's the cylinder stopper itself and the filter that goes into that. So that's what we call match compare. Now, let's use the same example that you know, I'm the maintenance worker. Now I've just confirmed, okay, I see the part that I need. Now I want to go into Physna, and I want to take not only the 3D data, but I want to add context to it with metadata that I could get from things like your PLM system or maybe your ERP system as an example. So let me come over to show you some metadata search. So I click here, I've got the part open, and now I want to actually look at the metadata for this part. So I'm going to go ahead and click on that. And in this case, I've got a stock location for where I can actually find this. I have what the cost is of the part, and I have the supplier that's been added in. But unfortunately, I can see that I have a quantity of 0. So all is not lost. I can actually click here on the assembly tree, and I can bring up the assembly tree kind of similar to what I showed you with the turbocharger. And I can see, okay, here's the 3 exact parts that actually make up that cylinder stopper assembly. So I'm going to go ahead and open those here in different links. And now you can see here's the filter. So I'm going to click on the metadata for that. I'm going to go ahead and do the same thing on a number of the other components. So what I can see is under the metadata, I actually have 20 of this specific part, and I can see the cost of it in the stock location. If I come back here, I can also see the same information specific to the cylinder stopper itself, and the same for the housing. So what I can do is I can actually go ahead and get from our existing inventory, even though I didn't have an exact, you know, fully assembled piece of that, I can get all 3 of those pieces. I know it's 100% accurate based off of the unique P&A that we showed. And we can get the machine back up and running. So let me transition to the last piece that I want to show you, which is all around classification. So we have a number of customers that we were talking to that said, I have millions and millions of parts, and I have to have different people on my team go through and manually categorize those parts. And it just takes an extreme amount of time. And they're like, it would be great if Physna had a way to be able to just give it a bunch of data. So here's a bunch of CAD parts, and see, can Physna do 2 things for me? Can it group those parts into general categories just based off of what we know from the P&A? And then can we also do something like create classifications and train, using machine learning and AI, train these models to learn what these are? So that's kind of what I'm going to walk you through and show you. So what you can see is here on the left, I have my unclassified models, and I have these groups that I was talking about that Physna originally came up with. So in this group, I've got some different threaded nuts, and as you start to go through, there's a number of different groups that were created from about 700 models that we fed it from a common part supplier that you could get at any big box store. So we created, Physna created classifications based off of some of those. So here you can see I have a threaded nut. If I come down here, I can see some of the other classifications. So if I click on self-leveling legs, you'll be able to see where I have these self-leveling legs. Now, I can do things like click on the predictions tab, and what's going to happen is Physna is going to run through all of those unclassified models, and it's going to say, based off of what you've already trained, I think that these models are actually self-leveling legs. Now I can look at that and I can say, yep, definitely self-leveling legs, and click on classify. Another example, if I come over and drop this down to, say, hand wheels as an example. So let me click there. I have these hand wheels. I'm going to do the same thing. I'm going to click on predictions. And while Physna is calculating that, what I want you to notice about these hand wheels is some have 2 handles, some have 3, some have 4, some are thinner, some are thicker, right? The point is these aren't geometric matches, but they're very similar to one another. And so you can see Physna said, hey, based off of like this confidence level that you gave me, I didn't find anything. Why don't you go ahead and try lowering the slider? So I'll go ahead and try lowering the slider. Physna will come back, and sure enough, it found, several other hand wheels that I can go through. So this is one way that it's very easy to do advanced classification. Another thing that we can do is we don't have to train these models from scratch. So if we have certain metadata, we have some customers that are like, I have some of my data that I trust, and I have some data that I don't trust. And because we're just not sure when people went through and added the metadata, if I can really believe that what they added was accurate. And so what we can do is take models with metadata that we trust and believe, and we can actually feed that to speed up the whole machine learning and training process. So that's kind of what I wanted to share with you guys today. And I'll go ahead and stop sharing. Bo, back to you.
Awesome. Scott, thank you. Okay, so first off, Scott, thank you so much for that deep dive into everything that we're doing over here. It's just really, really, really helpful. The last piece of this, it's like we really kind of want to focus on, and this is one of the bigger takeaways. And I started to allude to this in some of the conversation I had earlier on. Scott touched on this as well, is that good technology needs good process at the end of the day. It's in any company that's going to come and tell you, it's like, we built this really cool tool, it's automatic and awesome, and it's going to be great for you. It's always something. For any of us who have been in this business for a long enough time, it's like you always hear that with a bit of skepticism. And so we want to always say that it's like we're building really great technology. At the same point, we have to build really good process alongside that, which is where we have this deep and strong commitment to customer success and customer support, of making sure that people are really successful with our products, but also we're setting up the right practices so that's like they can find success over time, which is one of the reasons why I'm really excited that Andy's here and joining us to help answer any questions that we might have too. So with that, I'm going to go ahead and we're going to move into just a casual Q&A, where it's just to do a quick time check for anybody who's sensitive to that. We're at 1:39 Central Time, so 39 minutes after the hour. We can take about 10 minutes. We can also stay on longer. Additionally, if anyone wants to go deeper, we can also send out a link and you can set up some time to talk with us individually as well. So with that, I can go ahead and pull up the Q&A bot. And so we can see what we've got. And then I will go ahead and it's like, I will rifle through those and then pass them to the appropriate person who can answer them. I'm going to answer this one live. Aaron Smith asked, can you share data about dimensional data under different circumstances, say over time, temp, pressure, etc. Scott, I will toss that one to you.
So yeah, if I'm understanding the question correctly, so let's say that you have parts where you're gathering additional information such as temperature and things like that. That's probably a little outside of what we're actually looking for. It does depend on how you're using that data. So as an example, I mentioned that we can actually get metadata from other systems. So if there's a way that that metadata gives you context layered on top of the 3D data, then it would be something that we could definitely dive into and have a deeper discussion around. But at its core, we're really focused around the 3D, focused CAD related data.
Thank you, Scott.
Mhm.
Any other questions that we have for this, that you have for us, or that we can help answer at this point in time? You got it, Aaron. Going once, going twice. Sold. If there are any other questions, it's like, I'll give you one last shot. It's like you can raise your hand, we can allow you to speak, or you can type it into the Q&A box. I'll give a couple seconds for that. And if there are no questions, it's like, we'll go ahead and we'll close it out. Okay. With that, we just want to say thank you so much for joining us for this roughly 45-minute session on going into data integrity, but also understanding it's like the way that 3D data interacts with the models and reference architectures and in assemblies and sub-assemblies and all of the different cool things that you guys all build. What will happen next after this is it's like we will, for those of you who want to go back and reference this, we will send this to you in an email as a follow-up, as well as some other additional material to help you understand it's like our approach when it comes to these specific things. But you'll also get a follow-up email if anybody wants to go and dive deeper into these topics. We are more than welcome to spare some time and set up some time to chat. So with that, I am Bo Mangles. Thank you so much for tuning in to our broadcast. Scott, Andy, any closing thoughts from you?
Yep, just appreciate everyone's time and thank you.
Same for me. Appreciate everyone's time, and we're always ready to take further questions offline.
Awesome. Guys, thank you so much. Appreciate it.